Okay, April 6th. Engineering notation. It's similar to scientific notation, but there are some differences you have to know. Engineering notation. It's up at this. If you don't want to copy this down, it's up on the top of your chart. Here's the rules, okay? Remember, in scientific notation, there had to be one digit in front of the decimal, and it couldn't be a zero. Now, this is a little more complex. It's doable. You guys can do it. Has to be between, you can have between 1, 2, or 3 digits, between 1 and 3 digits before your decimal. Between 1 and 3, so either 1, 2, or 3 digits will work. Okay? Now, having only zeros does not count. So if you see 0, 0, 0 or 2 zeros in front of the decimal, that doesn't count. Now, you can count zeros. You can count the zeros as one of your 2 or 3, 1, 2, or 3 digits, or 2 or 3 digits. You can count the zeros as long as at least one of them is a non-zero. Okay, so if I have like 300 in front of the decimal, that counts. Okay, because I have a 3 to go with the zeros. Okay, if you have like 20, that counts. That'd be 2 digits because you have a 2 to go on with your 0. Okay. Okay, and also when you move the decimal, you don't move it one at a time. You move the decimal in multiples of 3. Okay, so you go like 3, 6, 9, so forth. Until you move it until you have either 1, 2, or 3 digits in front of the decimal. Okay, and if you move it left, you have a positive exponent on the base 10. And if you move it right, you have a negative exponent. Okay, so that's the rules. Okay, so now let's get started. Write in engineering notation, example 1. We have 62,500, so the decimal's here. So I move it in multiples of 3. So that's 3. Now how many digits are there in front of the decimal? There's 2. Remember, you can have 1, 2, or 3, so we're good. So I write 62.5. If you have zeros at the end, don't put them. Times 10. You moved it 3 places, so 3. And you moved it left, so the exponent's positive. Okay. Okay, example 2, and you type it up just like you did the scientific notation, 0.023. Now right now you don't have any digits in front of the decimal. Remember, that 0 doesn't count because the 0 has to have a non-zero digit to go with it. Okay, so I'd move it this way. Now there's 2 digits. Okay, so we just put 23.0. Okay, times 10, and I moved it right 3, so negative 3. Your exponent's going to be like 3, 6, 9, 12, or whatever, okay? You have 2 digits in front. Remember, you can have 1 digit, 2 digits, or 3 digits as long as one of the digits is not a 0. At least one, okay? Example 3. Negative 3,789. Decimals here. You have 4 digits in front. Remember, it has to be 1, 2, or 3. Okay, so I have to move it this way. Now there's 1. Okay, remember, it can be 1, 2, or 3. So negative 3.789 times 10. We moved it 3 places to the left, so it's 3. Okay, example 4. 959100. So the decimals here. Right now you've got 1, 2, 3, 4. Remember, you count the zeros because you have non-zeros. You have 1, 2, 3, 4, 5, 6 digits in front. Remember, you have to have 1, 2, or 3. Okay, now I have 3, so I'm good. So 959.1 times 10 to the third power, positive because I moved it to the left. Remember, in multiples of 3. Example 5, 0.0000375. Okay. So right now you have no digits in front of the decimal. Remember, you can't count the 0 unless there's a non-zero before. If there's a non-zero number with it. Okay, so you need to move it. You'd have to move it this way. So 1. Now I have to do another round because I still have nothing but zeros in front of the decimal. Okay, 6. So 3, 6. Now I have one non-zero digit. Remember, 1, 2, or 3. So 3.75 times 10. And we moved it 6 places to the left, to the right, so it's negative. So again, before that decimal, you can either have 1, 2, or 3, and they cannot all be zeros. That's your main. You can count zeros as long as there's numbers with them. Okay. Example 6. 357,000,000. So decimals here. So right now you have 3 digits, but you count the zeros, okay, because there's non-zeros with them. So we have to move that decimal, obviously. 3, 6. Now I have 2, okay, 2 works, so 35.7 times 10 to the 6th power, positive because you moved it to the left. Example 7. Negative 0.123456992. Okay, you need to move that decimal. There's 3. You still don't have, remember, you have to have between 1 or 3 non-zero digits. Right now you have nothing but zeros. Okay, you still have nothing but zeros. So you move it a third one, you have to add a 0 then onto that. Okay, so it's 920.0. If you run in the end, you got to put that. So 920.0 times 10 to the negative 9th power. Moved it right, so it's negative. So if you run out of room, you got to add a 0 to it, or maybe 2 zeros. So if that 2 wasn't there, I'd had to put 900. Okay. Now I have 2 non-zero 3 digits in front of it. Okay. Remember, 1, 2, or 3 is the rule. Example, and you move it in multiples of 3. 4, 7, 1, 0, 0, 0, 0. Remember, decimals at the end if you don't have it. So 1. Can I keep going? Yeah. There's 6. I should probably keep going. And now I have 1 digit in front. Remember, it can be 1, 2, or 3, not just 1 like in scientific notation. So 4.71 times 10, and I moved it 9 places, so I moved it left, so then it would be positive 9. Okay, so on all these examples, check your answers. How many digits you have in front here? You got 2. How many digits? 2, so it's right. It's got to be between 1 and 3. 1, 1, 2, 3, 1, 2, or 3. 1, 1, 2, 1, 2, 3. You count the 0 because you have non-zero digits with it, 920. Okay, then 1. Now you're like, I thought zeros don't count. Yeah, they do if you have non-zero digits with them. Okay, so that's how you check your answer. Again, you should end up with 1, 2, or 3 non-zero digits. Okay, that's pretty much what this assignment is about. Next problem, rewrite each conversion in engineering notation. So you got 1 horsepower hour equals 0.2647768 joules. So the decimal, this is the number we're rewriting, okay? So 3, can you do it again? Yep. So 2.65, round it when it's like that, 2.65 rather than write the whole thing, times 10, and you moved it 6 places to the left, so -6. Okay, next one. 1 erg, actually never mind, I guess they're going to want you to write the whole thing. 2.647768, which to me is stupid because the whole point of this is to abbreviate the number, but that's the answer, okay? 1 erg equals, I don't want you guys to get it wrong, so just 0.1, 2, 3, 4, 5, 6, 7. 7 zeros and then 7375616. Okay. So move it 3 times. Can you do it again? Yep. And then it would just be the 7 in front. Okay. And I want to stop there. Okay. So 7.375616 times 10 to the 6th power 36. And I moved it to the left, the right, the left. So it's positive. Wait a second. I screwed that up. That was, God darn it, Hermson, you are an idiot. 1 erg equals 0. I didn't see the decimal that was already there. 7737516. So the decimal's here, not at the end. So 3, 6, keep going. 9. Stop there. You got your 2 digits. So 73.75616 times 10 to the -9th power. You moved it right, so it's negative. Okay. Okay, last one on this one. 1 parasecond equals 3083740000000 kilometers. Okay. That's 1, 2, 3, 4, 5, 6, 7, 8 zeros. It's annoying having to count all the zeros. This time the decimal would be at the end. So 3, 6, 9. How many digits? I got 5 in front of it. That won't work. I can go another round. Okay. Now we're good. So 30.837. Remember, there has to be 1, 2, or 3 digits in front of the decimal in your answer. That's the main rule. 4, don't write the XX zeros, times 10, 3, 6, 9, 3, 6, 9, 12. 12, moved it left, so it's positive. Okay. Okay, then you get some evaluations you have to make and write your answer in engineering notation. So you got 3.08 times 10 to the 6th power times 8.2 times 10 to the 9th power. So again, break this up. It's all multiplication, no dividing. So I take 3.08 times 8.2, and then I take 10 to the 6th times 10 to the 9th. Okay, so 3.08 times 8.2, 25.256. And then with the powers of 10 and multiplying, you add the powers. 6 plus 9 is 15. So you got 25.256 times 10 to the 15th. You have 2 digits in front of the decimal, so that will work. Remember, it's got to be 1, 2, or 3, so I don't want to move it. Okay. Next one, we have 350 times 10 to the 9th divided this time. Remember, watch out for the division sign. Okay. Divided by 7 times 10 to the -6. So now instead of multiplying, we're dividing. So I'm going to divide 350 by 7. And then I'm going to take 10 to the 9th, divide it by 10 to the -6th. So I divide these. 350 divided by 7 is 50. Put a 0.0. You see there's at least one non-zero digit in front, so you're good. Okay. times 10. Now remember, you subtract, so you move that and then you subtract negative 6 from 9, but when I subtract a negative, it's like I'm adding 6, so to the 15th power. And that can be my answer, okay? I wouldn't want to move my decimal because I already have it where it belongs, 50.0. Remember, that counts as 2 digits before it. You count the 0 as long as there's another non-zero number with it. Okay, that's how that's going to work. And you can't move it again, because if you moved it again, you wouldn't have any. Okay. Okay, next one. I need to get a separate piece of paper to do these next 3. Mainly so you guys can see what I'm doing. Okay. So we've got, I forgot to put a parentheses there. 34.2 times 10 to the negative 12th times 543.6 times 10 to the 6th divided by 26.25 times 10 to the negative 9th times 15.2 times 10 to the 9th. Okay, so remember how you're going to break this up. You're going to first put your base numbers. So you got 34.2 times 543.6 on top. Then on bottom, 26.25 times 15.2. Meanwhile, with your base 10s, you have 10 to the negative 12 times 10 to the 6th on top. On bottom, 10 to the negative 9th times 10 to the 9th. Okay, you're going to multiply on both sides, 34.2 times 543.6. It's going to be, put that down, 18591.12. Put the whole number down. Then you take 26.25 times 15.2, 399. Okay, then I divide 18591.12 divided by 399. Okay, just put 46.59. You don't have to put the whole number on these. Okay, if you round, I'm not going to freak out. Okay. Times, now let's talk about our 10s. We want to add negative 12 plus 6. That's going to be negative 6. Okay, so you add on top, then you add on bottom. Negative 9 plus 9 is actually 0. Okay, so if I subtract 0, it's still negative 6. Okay, that's good. I don't need to move the decimal. I have 2 digits in front. Solid. Okay. You can always check your answer. Remember, you know if your answer is right if you have 2 digits, to 1, 2, or 3 digits before the decimal. You can count zeros as long as there's numbers without zeros. Zeros count as long as there's non-zeros with them, to go with them. And then your exponent should be a multiple of 3 every time. Like 3, 6, 9, they can be negatives, obviously. Okay. All right, next one. On top, we've got 25.7 times 10 to the 9th times 254.74 times 10 to the 3rd divided by 34.87 times 10 to the negative 3rd times 4.57 times 10 to the negative 9th. Okay. All right, so again, break up the problem. You're going to go 25.7 times 254.74. Then bottom, you got 34.87 times 4.57. Then you got 10 to the 9th times 10 to the 3rd, and divided by 10 to the negative 3rd times 10 to the negative 9th. Okay, so I multiply the top. Actually, there's a quick way you can do this if you have a good calculator. You can put the top in parentheses. Close it, divided by, and put the bottom in parentheses, 34.87 times Goes a little quicker that way. 41.08. I will not have to move my decimal because I have 2 digits in front of the decimal. Okay, we add, that's 10 to the 12th. And then we add down here, that's 10 to the negative 12th. This is not 0, okay? You cross that out, and you don't minus 12, you minus negative 12, okay? So it's plus plus, and that's 24. Okay, and that'll be my answer right there. Okay, last problem. Only one like this in the assignment, thankfully for us. We have 5 zeros times, I'm going to take out this negative here, I don't want that. Okay, times 0.00005 zeros, 0, then 5 zeros after it, 923. In the bottom, you got 0.5 zeros, 87 times 963, and a whole lot of zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 zeros. Whoever wrote this problem needs to be horse throat punched. Okay. Rewrite these in engineering notation. Okay. So I'll put the decimal at the end, move it in threes. Can you do it again? Yes, you can. So 73.2 times 10 to the positive 6 power because I was moving it left. Okay, here, move it 3 times. 3, go again. Now you're good. 9.23 times 10 to the negative 6th. And multiples of 3. 3, 6, 8.7 times 10 to the negative 6th. And then a lot of times 3, 6, 9, 12. And you can't go again because then you'll have 0 digits before your decimal. It has to be 1, 2, or 3. So 963.0 times 10, 3, 6, 9, 12 to the 12th power. It's positive. Then I do everything the same way I've been doing it, okay? On top, I got 73.2 times 10, 73.2 times 9.23. On bottom, I've got 8.7 times 963.0. Remember, you can do it all at once as long as you put parentheses around it. 73.2 times 9.23 divided by 8.7 times 963.0. 0.08, okay? And then you got 10 to the 6 times 10 to the negative 6. 10 to the negative 6 times 10 to the 12. Okay, I add these at 0, so put 10 to the power of 0. Add these, you get 10 to the 6th. Then I cross out the bottom every time and subtract that. 0 minus 6 is negative 6. But you do have to adjust the decimal because right now you can't count that 0 because there's no non-zero digits with it. Okay, so you need to move the decimal. So you move it 3 times, add your own 0, and you got 80.0 times 10 to the negative 6. Remember, if all you have is a 0 in front of your decimal, you don't count. That doesn't count as one digit. I try to specify that in the rules. Okay. It says has to be between 1 and 3 digits for a decimal. Having only zeros doesn't count. You can count the zeros as long as at least one of them is, as long as at least, I should reword that, as long as you have a non-zero to go with it. Okay.